What if there were problems that even the most powerful computers today simply cannot solve? This is where quantum computers come into the picture. Unlike classical computers, which process information in bits, quantum computers use quantum bits, or qubits. These systems have the potential to solve complex problems far beyond the reach of traditional computing. This could redefine computation. Classical computers process information using bits that exist as either 0 or 1. Quantum computers, however, use qubits that can exist in multiple states at the same time through a property called superposition. This allows quantum systems to process many possible solutions simultaneously. Another key feature is entanglement, where qubits become linked and influence each other instantly. These properties enable quantum computers to handle extremely complex calculations more efficiently. Problems that would take classical computers thousands of years could potentially be solved much faster using quantum systems. However, quantum computers are still in early development and are not yet widely used for everyday tasks. Their power lies in solving complex problems. One of the most promising applications of quantum computing is simulating molecules. Molecules behave according to the laws of quantum mechanics, which makes them difficult to simulate using classical computers. As molecules become more complex, the number of calculations required increases rapidly. Quantum computers can model these systems more naturally because they operate using the same physical principles. This makes them particularly useful for drug discovery and material science. Scientists could simulate how different molecules interact with each other at the atomic level. This would allow researchers to design new drugs more efficiently and predict how they will behave in the human body. As a result, quantum computing could significantly accelerate the development of new medical treatments. This could lead to faster and more effective therapies. It may reduce development costs and improve success rates in clinical trials. Another area where quantum computers could have a major impact is optimization. Optimization problems involve finding the best solution among many possible options. These problems appear in fields such as logistics, finance, energy systems, and transportation. For example, companies must determine the most efficient routes for delivery or the best way to allocate resources. As the number of variables increases, these problems become extremely difficult for classical computers to solve efficiently. Quantum algorithms may be able to explore many possible solutions at once and identify optimal outcomes more quickly. This could lead to improvements in supply chains, energy distribution, and financial modeling. By solving optimization problems faster, quantum computing could have a significant impact on real-world industries. This could increase efficiency and reduce costs. Although quantum computers are still developing, their potential is enormous. They are not meant to replace classical computers, but to solve problems that are currently impossible. In fields like medicine, chemistry, and optimization, quantum computing could unlock entirely new possibilities. Cut 4 words out of this sentence. In the future, these systems may solve complex challenges,